Today we're going to be looking at chemical equilibrium, and we're going to start from the meaning of chemical equilibrium systems in chemical reactions, and the lachetaliers principle. That's what we're going to be looking at in this video. So first, we're going to start from the meaning of chemical equilibrium. Now, the basic concept of the term equilibrium means something or parameters that are in equal proportions. When you have two different parameters, let's say parameter A and B, and these two parameters or variables, when they don't change with respect to each other in time, with respect to time, you can see that both of these variables are in equilibrium. A good example we can use is a seesaw. A seesaw is kind of like this, balanced on the knife edge. Now, when the seesaw is directly balanced with equal weight at both sides, you observe that there will be no motion, there will be no change in position on both sides of the seesaw. So you can say that the seesaw is in equilibrium when it is in such conditions. So chemical equilibrium is when a chemical reaction is in a certain condition in which the variables or properties of the chemical or the solution or whatever chemical variable you want to use doesn't change with respect to time. When variables like volume, concentration of the component elements, number of molecules, number of atoms do not change with respect to time, you can see that that particular chemical is in equilibrium. Now, looking further at the concept of chemical equilibrium, we would like to use a certain reaction as an example. So let's take a look at a saturated solution. We'll first take a look at a saturated solution of potassium trihydrogenate 5, which is KNO3. Now, KNO3 is in pellets or in crystals, as the case may be. So, which means that will be in solid state. And when it's in that solid state, when it's dissolved in a solution, it becomes a homogeneous mixture. So it becomes a certain kind of solution. And this is the solution we are talking about. So here you have potassium trihydrogenate with 5 pellets or crystal or solid, and here you have potassium trihydrogenate with 5 solution. Now, in this solution, this concept of equilibrium can be explained with this solution, where you have KNO3 pellets still precipitating above the solution. Now, that is because due to the way the system is stationed, due to the way the system operates, you have a certain quantity or amount of particles that will be dissolved in the water to form the KNO3 solution. But some parts of the water will dissolve some particles of the KNO3. So those remaining particles of KNO3 will continue to precipitate. Now, as those remaining quantities of KNO3 is precipitating, you have more quantities or number of particles of KNO3 dissolving at the same time. So that explains chemical equilibrium in the sense that when one variable is changing, for example, in this stage, the KNO3, when it is being dissolved, more KNO3 is precipitating to make sure that the solution remains the same or everything remains balanced. So that is the concept of chemical equilibrium. And then equilibrium systems. Now, we'll take a look at what equilibrium system means. Now, an equilibrium system is basically a system, from the word itself, system and equilibrium. When you have the word system, you have a composition of certain constituents working together, that complement one another. Then equilibrium, as we have rightly described, when two variables of a certain component are not changing, with respect to time. So you have equilibrium systems, and we have two equilibrium systems basically. We have static equilibrium systems, and then we have the dynamic equilibrium system. Now, for the static equilibrium system, it's basically an equilibrium system that the variables or the properties of the component is not changing, it's remaining the same. Just like the example I gave with the seesaw, when it is balanced with equal weight or equal masses at both ends, there won't be any motion in the seesaw, so it is in a static position. Another example, a chemical example you look is a glass of water, pure water, a pure glass of water with no solute in it. You see that that glass of water is not changing because everything is in balanced proportion. You have two atoms of hydrogen and one atom of oxygen to have that particular glass of water. Then looking at the static dynamic equilibrium system next. A dynamic equilibrium system is one that is changing, but as some properties of the system is changing, you have another reaction going on to balance up those changing properties of the system. Just as we looked at in the KMO3 example, where you had the KMO3 pellet dissolving, and as it was dissolving, some KMO3 pellets were precipitating again on top of the solution. And that goes on and on so that you can continue to have the system in equilibrium. Next, we're going to look at basically more examples under the equilibrium system. Now, for the dynamic equilibrium, we have equilibrium system occurring under the same conditions and under different conditions. So we're going to look at this example. Now, okay, now here we have a reaction between iron and steam, which is water gas. Here you have 3 moles of iron reacting with 4 moles of water, and steam, water vapor, gaseous water. So you have the reversible reaction, and when that reacts, it gives you this compound. And hydrogen. Now this compound basically is kind of ore of iron, which is known as magnetite. Now this system, as we see here, occurs under the same condition, where you have this occurring as great heat, and then this occurring also at great heat. So the forward and backward reactions both occur at great heat. This has to be heated to obtain steam, like water has to be heated to obtain steam, and this has to be passed over red hot iron in order to get the product you are looking for. So the forward reaction takes place at great heat, and also the backward reaction has to be done under hot conditions in order to get the iron and steam you are looking for. So this is for under the same conditions. And then let's look at under different conditions. Now, under different conditions, we're going to look at the decomposition of ammonium chloride to give you ammonia gas and HCl gas. So when you have ammonium chloride decompose reversibly to give you ammonia and HCl gas. Now, for this reaction, the forward reaction, which is the decomposition of ammonium chloride to give you ammonia gas and HCl gas, is done as by applying heat. Now, definitely, it's a decomposition reaction, and most decomposition reactions occur when you apply heat. When you want to decompose, break down something into its constituent units, one of the ways to do that chemically and even physically is to apply heat. So when you want to decompose ammonium chloride into its constituents, which is ammonia gas and HCl gas, you have to do that under great heat. So application of heat to ammonium chloride leads to the decomposition of it into its constituents, ammonia and HCl. However, when you want to get this back, get back the ammonium chloride from HCl gas and ammonia gas, it has to be done under relatively low temperature. So that is carried out under cold conditions. In order for you to get this, carrying this out, the reaction between ammonia and HCl under optimum temperatures or high temperatures won't give you the product, ammonium chloride. It has to be carried out under relatively cold temperatures. So you can see that dynamic equilibrium, or even equilibrium in general, can take place under the same conditions and also under different conditions. Now the next thing we'll look at is the lachetaliers principle. Now, lachetaliers principle basically tries to explain what happens in equilibrium. We looked at dynamic equilibrium as we took a look at how dynamic equilibrium works. So lachetaliers principle tries to make us understand what happens when one property of a system under equilibrium changes. It tries to explain what has to happen for the system to remain under equilibrium. Now, roughly, lachetaliers principle is of the idea that when a system is under equilibrium, the properties that keep it or sustain it under equilibrium, when there are certain properties that keep it in equilibrium, lachetaliers principle tries to explain that when one or more of those properties change, another property will have to change in order to shift the equilibrium position so as to balance the initial property that changed. So looking at an ideal statement of lachetaliers principle, which I'll write out. Now, from what we have on the board, you see that lachetaliers principle states that if a chemical system is in equilibrium and one of its properties or factors involved in the equilibrium changes, the equilibrium will shift in order to neutralize the effect of that change. Now, like what I said earlier, this principle is just trying to explain what happens in a chemical system that is in equilibrium. Now, breaking this down, it says if a chemical system is in equilibrium and one of its properties or factors involved in the equilibrium changes. Now, we consider a system under equilibrium, and then we take, for example, the factor that is changing is temperature. Now, when one of these properties changes, the equilibrium position will have to shift from its initial position to another position in order to neutralize the effect. That the effect caused by that first factor that changed will have to be neutralized, will have to be altered, and for that to happen, so that the effect of the first factor that changed may be felt, the equilibrium position has to shift so that everything remain balanced, because we said that the equilibrium system is a system that is relatively balanced. So for the system to remain balanced, the equilibrium position has to change, has to shift in order to neutralize that effect, the effect of the first property that changed. One example I'll look at is water. Now, taking water for example, let's say you have water in a vessel, a closed vessel, or just a vessel. Water in its liquid state can reversibly evaporate and condense back to liquid. So let's have water as indication state, which is steam, popularly known as steam. Now, we'll see that for this reaction to occur, the forward reaction, which is the water turning into vapor or steam, the first thing that will happen is that you have to apply a certain quantity of heat. Taking, for example, you have the water in a vessel and you heat it to a very high temperature of above 100 degrees Celsius. Let's say you heat it to that temperature. You have altered the temperature of this equilibrium reaction. And since you have altered the temperature of this reaction, another factor will have to change in order for this to remain in equilibrium. So since you have altered the temperature, in trying to convert this to gas, the equilibrium position is going to change. So when you add, when you heat it, addition of more temperature will have to lead to the release of more steam in order to keep this system in equilibrium. And then when condensing this back to water, you are going to reduce the temperature in order for it to condense back to liquid. And when you do that, in order for it to remain, in equilibrium, more quantity of water will have to be produced. And how will that happen? By the absorption of heat. So that is what lachetaliers principle basically is all about. It's basically about telling us what happens when one of the factors responsible for the equilibrium of a system changes, and what happens for that system to be neutralized.
Yeah, bro.